that's his last name. Like.
Oh, Furniture Walla. That is so funny. I like that you know what that means. Okay, cool. It's recording. I'm gonna have to trim this though.
Yeah. So.
Oh, we should just start. Oh, word. What did you say then?
Oh, yeah, Varun was telling me that he would he'll call his friends like random wallows like.
That's pretty funny. Okay, let's do it. Let's just. It is recording. Yeah. Yeah. Okay. Good afternoon, class.
Good afternoon.
Good. So today begins like the end basically. So okay, let's look at the game plan actually. Let's look at month. Okay. So actually, let's look at year. Yeah. Okay. So this is how much time is left until December 6th, I believe. I think 9th marks the beginning of reading days. Right? 9th is the last day of classes, I believe. So this week is dead. So we effectively have next week, then this week, Thanksgiving, and then the following week, and then that's it. So here's like the game plan for the rest of the semester. Homework 7 is due on Monday, October 28th. Everyone clear on that? I would start that now, just because like, I don't know, Campus Wire is going to be like more dead on the weekends than it is alive, right? Just because we're like TAs, we like do things. But we will still be active. So I would start that as soon as possible. And what I'm going to do is so after homework 7, so homework 7 is the last homework assignment for this class. So no more like grade scope tests, like kind of things after that. After this, it's just the final project. The final project is basically like the culminating thing for the JavaScript class. It's pretty much why I assume people take the class, is to do the final project to really feel like you know JavaScript. So even if you feel like you know JavaScript through the homework assignments, you really don't. You only really know how to program in JavaScript once you've built like an entire application in it, and once you have like dealt with like the bugs that everyone else kind of deals with. So final project is really up to you, like what you want to build, but it just has to be like sufficiently complicated. So in the past, we've had final projects like one of them was really cool. He used this thing called 3.js, which is like a 3D rendering library for JavaScript. And basically, he made it a multiplayer thing where anybody in their web browser could go into this 3D world and then draw on each other's like whiteboards. So he basically had this like virtual like classroom space, which was pretty sick. I built like when I took the class my freshman spring, I built this thing where anyone could like join different classrooms, like virtual classrooms, and like draw on like 2D canvases, which is where I think he got the idea for last year, but he turned it into 3D. And so basically, like it would just be like real time drawing, like with your friends. Or the use case that I pitched was that professors like might want to be able to use their tablets or their phones to draw on like the screen, but you shouldn't have to have like a tablet that's only compatible with this system. You should be able to do it over the web. And I guess like other ideas have been, people have done like complicated to-do apps in the past. Those don't sound super fun to build, so I don't know why you would spend many hours building them. So anyway, yeah, the idea is to have fun with it and to build something that is intriguing and interesting and that you'd want to show other people and say, hey, I built this, and have them be excited about it. So I'll post like more information about that on Friday. Final project in general comprises of 3 milestones, where the 3rd milestone is the final milestone. So before the first milestone is due, we need like a project proposal, right? Like what do you want to build? What are you going to accomplish in your milestone 1, milestone 2, and milestone 3? I'll post more of these requirements tomorrow. And then basically after that, so really look out for Campus Wire posts tomorrow because there will be like deadlines that I'm going to assign. The first main thing is 1 project proposal. We are going to review that as a team and figure out which proposals need revision, which ideas are too complicated, too easy, etc. Then what you need to do is schedule like a phone call or go to a TA's office hour so you can talk about your proposal, and the TA can kind of help you out with like identifying, because we've all been programming for quite a while in JavaScript, so we know like the general landscape, the libraries that are out there. So it'll help you kind of funnel down like the libraries that you might want to use. After that, we'll have milestone 1 do sometime in, so milestone 1 will probably be due the 8th, then we'll have milestone 2 be due the 15th, and then we'll have milestone 3 be due either like right before Thanksgiving. Yeah, we'll probably have it be due like right before Thanksgiving, so you guys can like all kind of chill. Or if people need more time, we can run into like the week after that. But then anyway, so on the 3rd, so when is the class? When does the class meet for 19X? Is it Wednesday or Tuesday? So anyways, I think I should be able to get the classroom on that Tuesday, and then we'll have this classroom on this Thursday, so December 3rd and 5th is when we'll do like final project like presentations, and then I'll try to snack some pizza for like the 5th, and then just have like a little party, and we'll kind of call it on that day. Sound good? Any questions about that game plan? Okay, so now the lectures. So what we like to do is introduce like kind of like fringe, like everything you've learned so far in this class has already been developed like a year or 2 ago, or maybe like 3 years ago, and now is like relatively standard, but you know the standards keep changing a little bit. So the remaining lectures are to help you catch up to current standards or learn like new technologies that are emerging. So these are kind of the topics that we have that we think are pretty useful. So I'll probably put a poll out to see like which topics like people are generally interested in, and then we're going to make lectures for these over the next few lectures. So now is like really when like the fun starts, I think, where you actually get to see like what's like how far can you take this language and how far can you really stretch your like web application abilities. So the first one is like building a full stack application with like authentication with the database, maybe with like a real time component, just so you know what it looks like end to end. So that's like one possible topic. 2 is like front end routing. So a lot of times if you notice on websites, so for example, if you go to the JavaScript website, like notice how like the website, it doesn't like reload, like you don't see that reloading symbol here. That's because but you see that this path has been changing the entire time. This is something called front-end routing. It helps your applications be like pretty fast because you don't have to make like network requests like over and over again. So we can learn about that. There's also this thing called Gatsby, which is this like dope web framework that Cameron, one of the TAs, is like a huge evangelist of, and it makes like programming like quite incredible. Apparently, I haven't learned it yet. And then we have this thing called React hooks, which is like a new thing in React 16. I looked at them today, but I didn't feel comfortable enough teaching them, but they're pretty sick, so I kind of want to teach them. GraphQL, which is this very, very dope query language. So you know in like the last few assignments how you had like the server-side API, you'd make GET requests to get data, POST requests to like change data, and you'd have to do that for every single type of data manipulation that you'd ever think of. Does this ring a bell? Right? So GraphQL says, okay, we shouldn't be doing that. That's like way too much server-side code, and the maintenance, the overhead is like too high. So on the server side, you're only going to have one endpoint, and then your front end is actually going to make like queries like intelligently. So basically, your queries look something like under GraphQL, your queries like if you want to get all users, you literally might send a string like users to your server, and that is just going to hit that one endpoint and retrieve all of the users. So it's extremely, extremely efficient for building like CRUD apps or things with like any application that uses a database. It's like a nice wrap around it. React Native. Has anyone heard of React Native? Okay, yeah. So React Native is basically, so we more or less know React now, but what you can do with React Native is write mobile code. So basically, like you can write React code, it's going to compile down to iOS and Android builds, and then you can run it on your actual phone, which is pretty sick. And I think I believe in this technology. And then the last one, which I don't like, maybe we could do it, is like web services. So if you want to build like a microservices, like an application that uses the microservices framework, could talk about like how to do that with like Node and then like maybe like Java web. So basically, the idea of microservices is initially you have like a monster application. And maybe the application has like tons of different functions, but people are constantly pushing and updating changes to it. But that's not super great because if any small part of the application breaks, it's easy for the whole application to break. So if you split up the application into many different services, or basically many different servers, on each server you run a small subset of the functions of the initial application, then it's a lot better because each team can kind of manage their own like subset of functions that they need to handle. So anyways, there's a way to do that quite easily with like JavaScript or like Node web services. So if you guys want to like learn about that, that could be dope. Not really useful for like final projects, but more so when you're like working at scaling companies or like large companies that handle like a high number of requests. Yeah. So right off the bat, does anyone have any suggestions to add to this list so that I can think about it? No? Okay, cool. I guess last thing on this like logistics area is that we are going to be probably looking for like new TAs, I think, probably. So if you're interested in TAing for the class, so basically if you took the class and you did like well, and I think you did well, then you should be like good to go for this for TAing. It'll probably consist of just like a small interview, not a coding interview because I know how you code and I can look at your code now. That's basically it. So I'll post more information about that later, and then we'll probably do like TA interviews over reading days, and those aren't really things that you prepare for more than like 10 minutes, so it shouldn't like stress anyone out. Cool. Everyone good on that? Okay, cool. So now I want to talk about last class we built that React like to-do app, if people remember, right? And the high level. Kind of like the high level steps we took there was, okay, like one, like what actions do we want to be able to do? Two, like what do we want our front end to actually look like, right? Remember, so we like kind of like drew it out, like figured out like what the front end application should look like. And then after that we said, okay, how can we break this up into smaller bite-sized components that we can actually program? And then we went ahead and actually programmed them, right? That's the general framework for building like front end only apps. For this is like my framework for developing like any kind of like web app. It's like this like 8-step process, and I'll kind of just walk through it, and we'll go through this like today as well, like to some extent. So the first is like kind of figuring out like the scope of your project and the different features that you want to be able to support. So for example, for a to-do app, it's like I want to let users like add to-dos, like delete to-dos. Maybe I want to let them add it to their calendars, which means they need to be able to like have we need to be able to have an integration with like iCal or like GCal. Maybe like I want users to have points for completing their to-dos, and maybe they get rewarded at certain like point benchmarks, like that kind of thing. So figuring out what are the features of your application. Then two, mocking it out on the front end, which in our case just meant drawing. But typically, and what I think would be easiest for people is to use Figma. Figma is this really dope like front end UI mocking tool. It takes like 10 minutes to like learn how to do. They have like this great video series that they've released. So highly recommend that. And then three, I guess I could just write that. Who cares? Figma. It's like Ligma, but with an F. And then three, we have your backend API. So you kind of want to define your API, like what are the different routes that you want to be able to support. So for example, if it's a to-do app, you want like a post request for adding to-dos. You want a get request for getting the to-dos. Maybe you want like a login, like a post request for logging in, etc. Then 4 is I usually code my backend first, just so like I have something to play with. And then 5 is like I take my mocks and I turn them into front end components, and I figure out, okay, like what parts of this application are going to turn into which components. Then I build a very bare bones front end that looks horrible, but it's functional. Like I want to build like an MVP, like a functional version of my application. That doesn't integrate with my backend yet, but I want to make sure that all of the different components are there. Then, like step 7 is I do a front-end backend integration and saying that, okay, my front end is able to successfully talk to my backend in the framework that I've outlined as like a developer. So basically saying like different rules, like okay, only if a user is logged in should they be able to do these different front-end actions, etc. And then finally is like prettify the front end, and in between each of these steps is like bug fixes, right, and like testing, I guess. Yeah, I guess we haven't covered like, so I guess like one, I don't think anyone's gonna fight for this, but if we want, we can do a lecture or maybe a half lecture on like testing. So like unit tests, if you want to learn how to do that. I think you could probably like read an article on it, but we could also talk about it because there's like some catches there. Yeah.
Nothing about automated testing.
What do you mean by automated?
Like automated, like tools for automated like test, automated testing. Like is that a thing?
What do you mean by automated though?
Like
not writing your own tests?
Yeah.
Oh, you mean like load testing?
I think so. Yeah.
We could do that. I haven't done that. That could be fun.
Yeah.
I think what he's alluding to is like if you have like a node server and you want to make sure it can handle like a certain number of requests per second, perhaps like every so often or like randomly throughout the day, you can like just like send it like millions of requests. Okay, we could talk about that. Cool. So does that framework kind of make sense? So far we've done okay, cool. So I want everyone to keep that framework in mind when we go into the second half of the coding portion of today's lecture. In the first half, I want to make sure that people kind of understand, okay, who has started the homework? Okay, good, very good. Who attended last lecture? Who has caught up on the lecture material or understands what this lecture hinges on what I talked about last lecture. Okay, whatever. So.
It's recorded, we're good.
It is recorded, yeah. Okay, so last lecture I talked about React, and I also talked about Redux. Just to recap at a high level, React allows you to build your where's the yeah.
We also turn off the lights on top of this.
Oh yeah, I'll do it when I start coding. So React allows you to build front ends that are modular, which means you can reuse different portions of your front end, and also are rich with data that is changing constantly. So you don't have to handle state changes. React is going to take care of that for you, and React also provides a nice way for you to build out your front ends from small components. Okay, just repeated myself 3 times. That's okay. Now, what we did in the first step of last class, so if everyone remembers, each React component gets access to its own state. It can pass state change handlers down to its child components, but no one directly has access to a React component's state, right? And what we did in the to-do app is we said, okay, each to-do, we had this application, right? At the top we had some title, then we had a container. Oh, yeah. We had a container, and then in here we had an input, right, where you put in what your to-do is. Then we had an add button, and then for each to-do we just had whatever it was called. I think we had groceries, right? And then we had broccoli spelled with the 1 C, right? And then we had an X to remove it. So what we said is, okay, let's have this component that encapsulates all of this. It's going to hold on to the state, which in this case is basically a list of to-dos. Then it's going to pass that state down to each one of these smaller to-do components. And whenever a change needs to be triggered, so for example, when someone clicks on this X within this component, it needs to tell its parent component that the state has changed, such that broccoli is removed from the to-dos list, right? Then what we said is, okay, it's getting kind of messy because the state of all the to-dos is captured within this component, but when someone needs to make a change, so let's say I have this component, which is this overall container, then I have this component, which contains both the to-do item name as well as this button that is nothing other than a trigger for deleting that to-do item. And then I basically have this button, which could be its own component. So in order to actually make a change at this top level, such that an item is removed, so in order to make a state change at this top level, what I need to do is pass a handler down to this component, which in turn is going to pass the handler down to this component. Now that's kind of stupid because this outer component really has nothing to do with that handler other than just passing it down to its child component. So what we said is that this is kind of stupid. What we should do instead is abstract out the state, and any individual component that wants to access the state can do so explicitly. So then instead of having all the state distributed across multiple smaller components, and the state is kind of distributed in here, there's handlers getting passed throughout all these components. We said, why don't we just have the state be this top level object, and components can request state through that map state to props function, if people remember somewhat. You can request state through map state to props, and you can change the state by dispatching actions. People kind of remember? Okay. Okay, so we're just going to talk about this top part on its own. How does Redux work just by itself? Then we'll try to integrate Redux into, or we already done the integration into our to-do app from last time, so we'll just recap what that app looks like. Then we'll add an API server, and then do a little bit of the front-end, back-end integration that I talked about. And yeah, sound good? That's my game plan. Okay, so Okay, so should I kill that one? No. How about this one? Is that better? Should I kill another one?
Yeah.
What about this one? It's kind of dark. How's that? Too sleepy or? I thought that was someone with their mouth. Okay, so first off, what I want to be able to do is be able to serve. So in order, I'm going to make like a counter app, okay? It's going to be very simple. Basically, our page is going to look like this. No React. It's just going to have like a count, which is going to start at 0. We're going to have a button that says up. We have a button that says down. As you can imagine, when I press the up button, it's going to decrement this, and when I press the down button, I increment this, right? Cool. No one caught it. So what I need first is the ability to send an HTML page to my client. How do I do that? Anyone have any ideas? It's in the name of this file. I have to build a server. Amazing. So I'm going to do that, and here's how we build a server. So we first get Express, right? Then we make this thing called app, which is the execution of Express, and we can listen on our favorite port 3000. And when it's listening, or after it's listening, we're just going to log to the console that it's listening. Then I'm going to say whenever someone requests like the slash route, I'm going to go ahead and send them a file. That file is going to be index.html, and that's going to live within our public directory. Okay, so let's go ahead and make that directory. So we're going to make public. Okay, now we have public, and then we're going to make public index.html. Mkdir makes a directory, and then touch creates a file. Okay, so now I have this index.html. Let's go ahead and, let's just make an HTML document. Redux example, okay, and then we're going to have a body. And then let's just say like Redux, okay? And the server is basically going to send the file available at dir name public/index.html. Everything clean so far? Okay, so now if I run, the server, we see it's listening. I go to Google, go to localhost, we see that the HTML file is being served. We got our server up, great. So there's a second thing we want to do is to be able to use Redux. So if you notice in my package.json, I've already included Redux. Let's actually get rid of so ignore these other ones. But Redux is basically this whole like state management thing that I talked about earlier. So what I can do is import like a few things, right? So let's start. Yeah, now I'm beginning Redux. So this thing at the top that contains the state is called the store. The store stores the state. Just think about that, okay? So from Redux, in order to create the store, I have to import this function called createStore. And that comes from the Redux library. This is ES6 imports. Anyone unfamiliar with this? We feeling it? Good. Okay, so createStore takes, so we can create the store by calling createStore. Now createStore takes within it a function called it's called a reducer. Okay, so last class I called it the state manager, but in this class we're going to call it the reducer. The reducer just basically takes the previous version of the state and an action that gets dispatched to the store and computes the new state given these two things, right? So it's like you have the previous version of like how the world was, then you have a new action that is being applied to the world. I take both of these together and I should be able to create a new world. Does that make sense? Okay. So in this case, we're just going to create this reducer, which we called state manager last time, which takes in two arguments, and the state and action, and it's going to return the new state given like whatever action is provided. This reducer is the argument to createStore. Okay. So we can also set default parameters in JavaScript. So let's say the state should start at 0. Right, because we're making like a counter, so 0 should be the ideal starting state, or 1, depending if we're in some other place. But anyways, so whenever we want to be able to identify actions by like different types. So for example, if I get an action of type increment, I want to increase like, the state. If I get an action of type like decrement, I want to like decrease the state. In this case, the state is a counter. Usually, it's going to be like an object, or in this case, the state is a number, but usually it'll be like an object or something. So let's just say let's just handle like the increment case this time. So if the action type is equal to like inker, so this assumes that action is going to be an object that has a property called type. Does that make sense so far? So if I see this, then I'm going to return plus plus of state, which increments the variable and then moves on to the next line in execution. Actually, if that's confusing, let's just do, we'll just return state plus 1. Okay, it's a new number that's being provided. It's important that every time you return from this statement, it is a new object or it is a new copy of the state. That's super important. You can't just like modify and return. Yeah.
I was gonna ask.
Yeah. Okay. So let's say like, okay, so now we have all of this like kind of set up. I'm gonna come back to this in just a second. Let's go ahead and like set up our HTML page so that it looks like something like this, right? So we're going to have the count. Let's say the count is a p tag with ID count, and then we're gonna have a button called up with the ID up, and then we're gonna have a button with the ID down, and that's just gonna say down, right? Let's go ahead and just see what that looks like. Up, down, and we have the count. I guess we can just initialize it to 0 like that. Okay, everything good so far? So we have this. Nothing happens when we click this up button. Nothing happens when we click this down button. So first of all, if someone clicks on the down button or on the up button, I want to be able to dispatch an action with type inker. Does that make sense? Like that's the ideal thing that we want to be able to do. So let's go ahead and get like the up button, or let's get jQuery, because that'll make this a lot easier. What I'm doing is not like unfamiliar, right? Everyone knows what I'm doing right now. Okay, so I'm basically getting like the jQuery library. I can get the jQuery library from cdnjs.com, which is like a content distribution network. And this is basically like a network of servers that host static files, such as like the minified jQuery file. A minified file is basically like a compressed file. Yeah?
I'm not going to use a dumb question, but if
No dumb questions.
Starting a static file,
Yeah.
why can't you add as a package.json and then put it through like your node modules?
So I want this library available. So there's like two things there, right? One is I could do that, but what I need to do is I still need to be able to like require that file, right? So, oh, are you saying just like import it, have it be available in my node modules, and then just access it through there? Yeah, you could do that.
Oh, okay.
You could totally do that.
Just most people don't do it.
Yeah, you don't want to be like requiring things from within node modules. You should actually never like touch node modules.
Okay.
Yeah. If you ever want to make a change to a package also, like you should like fork it and then like make your own version of the package and then have that in your own like public / JavaScript like lib. Like you should not edit node modules. Because anytime anyone reinstalls, it's just gonna wipe out everything you changed. But also like in general, you don't want to peek in there either.
Oh, I don't think can we install it into node modules from like package.json?
Yeah, you totally could.
Okay.
You could do the same thing.
Functionality difference?
Well, kind of, right? So you're going to be running your, it could have to do with like load times. So for example, like that file is only going to be available on my server, but whoever accesses my file and requires from like this CDN is going to get it from the closest server available to them that the CDN owns. So it could like make a difference in terms of load times. In terms of functionality, it won't make a difference at all. So now on this HTML file, I want to be able to add jQuery JavaScript, right? Now note that this. So okay. So first of all, even if I console log here, and I refresh the page, and I look in the console, we see that this line is not being executed at all. Can someone tell me why? Go ahead and look over here, and maybe someone can tell me. So I have this file called index.js. I want index.js to be run on the front end. When someone makes a request to my server, they get this index.html document. This HTML document has these lines. You can read it. This line is basically just jQuery. But when I refresh this page, it should be executing console.log hello in the console over here, but it's not. Can someone tell me why? Yeah. Perfect. right? There's no way to access this index.js file from my HTML. Like it's not like accessing this JavaScript file. So in order to be able to do that, there are a few steps. Okay, so the first of which is every time. So the first of which is we need to provide a way to access static files from like the front end, right? So which includes like this like JavaScript file. The second thing is remember that browsers, not all browsers support ES6 yet. So we need a way to transpile from ES6 to ES5 into a static file that we can get from our browser. The third thing is we see here, like even if we were able to transpile this from ES6 to ES5, this import from Redux thing, like that is accessing a package that's in our node modules folder. That's kind of an issue because even if we transpile this from ES6 to ES5, it's still going to have this import statement. And once that comes to your browser has no idea where to get that file from. So what we need to do is not only transpile this file into ES5, but this file and all of its dependencies into an ES5 static file, and then be able to require that or request it from the front end. Does that make sense? Like what we're running into? Okay, cool. So the way we do that is we use Webpack. What I talked about Webpack last time, it's basically like a transpiler. Okay, and the Webpack. So in order to run Webpack, you just need this thing called the Webpack config file, which is normally titled webpack.config.js. Now, I already had this from the last time we coded together, so I'm just going to copy paste that, and I will also explain what's going on. So let's go ahead and like kill this, because we don't need this. So basically, it just needs an entry point and an output point. So our entry point here is called appdir. In this case, it's literally just going to be the current directory. And we're going to enter at index.js. We want to output. We're just going to output at public. So actually, let's make this even cleaner. So we'll just have dir name plus /public /public. Okay. And then we don't really need this, but I just kind of have it there. So basically, Webpack is going to go in to your entry point, which in this case is the current directory, index.js. It's going to go in here, look at all the different dependencies, and then recursively go into each one of those dependencies and continuously keep transpiling and like appending to like a very large document. Okay, that's all that's going on here. Then what I have in my package.json is this command that I wrote. So build. So under the script section, I have this script called build, and build is going to run webpack -- watch, which basically means if I make a change to any of the files that Webpack has transpiled, then Webpack is going to retranspile. Make sense so far? Okay. So now if I run npm run, so let's just remove the watch for now. If I run npm run build, so npm run looks within the scripts section, by the way. So that makes sense? Okay. So we see that it went ahead and it built this thing called bundle.js, and we see that bundle.js has been pooped out over here under the public directory. So if I click on this, it's like this fairly unreadable, like enormous document. But basically, this document includes Redux as well as the different lines of code that I've written in index.js. So the last thing to do now is to be able to access this bundle.js from the front end. Does everyone see like the chain of things that we're doing? Is everyone following? Okay, cool. If you have a question, just raise your hand or say it. So what we want to be able to do is just have a script that accesses bundle.js. Okay? Ideally. So basically the last thing we need to do now is make sure that we can access this file from like a quote-unquote static directory. And I've done this like a few times now. So if people still have questions, I can go over this. Basically, express.static is a middleware that declares a certain directory as a static directory. And then app.use is using or registering the middleware with the application. So now whenever a request comes in, it's first going to see, does this GET request match any file name that is within like the static directory. If it does, then I'm going to return that file. If it doesn't, then I'm going to continue going on in the middleware chain, like I talked about last time. Yeah.
Why do you call it a static directory?
Static files. It's just like all static files that aren't like really going to change once your application is up and running. Okay, so now I'm going to restart my server and go ahead and refresh this page, and let's see if it, and then now we see the hello showed up. People see the chain of events? Okay, cool. So now that I'm here, I have this store, I have jQuery. What I can do is when someone clicks on the up button, I want to go ahead and dispatch, so store.dispatch, an action with the type inker. I can dispatch an action directly to the store. That make sense here? Okay. And this is jQuery. Remember with jQuery, only use the function keyword because jQuery relies on the context from what people, if people remember. Okay. Okay, the thing is, so let's just go ahead and console log this action just to see that it's coming in. Okay, and I'm going to run this webpack watch command, webpack with like the watch flag, which basically is going to continuously retrans file. And now we see it's going to watch, and so if I make any changes, it's going to rebuild. So now I'm going to go over here, refresh the page, and we see that this action got, or this is like a background action. But anyways, if I click up, we see that inker keeps getting dispatched, and the state is changing, or the state may or may not be changing. We don't really know yet. But this value is not being reflective, is not reflecting the current state, right? So how do we kind of create like a listener that is fired every time the store or the state changes? What we can do is subscribe to state changes by using store.subscribe. This takes in a function that is executed anytime there's a change to the state. And so now what we can do is we can say, let's get the current state. So current state is equal to store.getState. And then we can just have, I forgot what it was called. I think it was called count. Let's check though. Yeah, so get the element with the ID count and set the text of it to be the current state. Okay, and we can just log it just to make people comfortable. So I can refresh this page, click up, and we see that it's like going up appropriately. Make sense so far? Okay. And now, if the action type is equal to decker, then I want to return state -1. And basically, we're going to have the same logic down here, but instead of up, it's going to be down, and instead of inker, it's going to be decker.
Did you ever like declare that variable cur state, or is that just like something that it should?
Yeah, right here.
Oh, okay, cool.
No, that was a good question. We should not be using variables before we declare them. And then I refresh this page, up, down, down. Got it? Okay, cool. So that's basically everything with Redux, okay, so kinda. Ooh. All right, so now let's like introduce like a little bit of convention. So instead of doing this like instead of doing these if statements, typically only one action is ever going to be introduced, and you should only be doing like, yeah, and for each action there should be at most like one state mutation, which could be as complicated as you want. But so now is like probably the only time I've ever used switch statements within JavaScript. We're going to switch on the action type. So implicitly, you're making the assumption that every action that's coming in has a type property, and that's like a safe assumption. So now we can case on the different action types. In this case, we have inker, and then we have, in the case of inker, we return state +1, and in the case of decker, we return state -1. Everyone, people remember what switch statements do, or can infer from this block of code? Okay, cool. Refresh the page, and we see that it still works, which is lit. And we'll just remove these log statements. Right? Okay. That is the crux of like Redux. This is like basically everything you need to know to like build React applications, or everything you need to know from the Redux side. And then we'll go over like what the React side looks like in just a second. I think the last thing to note here is that we can actually have asynchronous. So okay, let's do a little bit more actually. Typically, what we want is the ability to abstract away. So notice how these like types are strings, right? Imagine this dispatch is happening like somewhere in some other file in my application, and for some reason as a developer, I need to remember that the two strings are exactly the same. That's kind of stupid. Like I shouldn't have to do that. This is like such an easy way to introduce bugs into your application because you might have like misspelled a different action, and you might have like thousands of actions in your application if you're like Facebook or something. So what we'll do is create an object called types, and this is going to hold key value pairs, which are basically going to be the different action types in my app. So instead of accessing incr like that, I'll do types.incr, and then I'll do types.decker, and then here I'll do types.incr and types.decker. Okay, do people see why that's useful? The reason why it's useful is that like now I don't have to remember how to spell the specific string. Now I can just like access, like types.incr is always going to be types.incr. Like types.incr is always going to be equal to types.incr. That make sense?
It's only useful if you like change the words from incr because it's just the same thing, right?
Well, this just has to be like any string that's like not equal to any other string in your object.
Okay. Well, is it useful because like if you write something that's not an existing type, they'll get caught like earlier?
That is also true.
Isn't that like why? Is it useful to type the same words out?
Yeah, I mean, in that case, like, as long as I'm not casing on undefined, then it'll be fine.
Right.
Or then it'll get caught, and I'll know something's wrong.
If you use strings, oh yeah, I see. Yeah, you're not casing.
Because now I'm using like strict string equality in the switch statement. Okay, and let's talk about that later. But so quick side note, you can actually with JavaScript, like we've talked a lot about asynchronous code, right? So when you make like requests, you're going to asynchronously handle them when the requests receive some response from some external server. Now you might be asking, okay, Redux seems to be really just like it seems like quite synchronous, but there's a way to introduce a way to handle like asynchronous code within Redux that works out like quite well, and we'll talk about that super shortly. Okay. Okay. Any questions before we move on? Okay. So what I'm going to do is kill this and close it, and now we're going to go back to our application that we had from last time. So just to remind everyone, let's see if this still runs. I made some changes earlier. Was it this? Okay. So I'm running Webpack Watch for the same reason as last time. And I'm running npm start, which is just going to start my server, but it cannot start because the port 3000 is currently in use because I didn't kill the server from the other project. So what I'm going to do is go ahead and do that. I'm going to kill this, and I'm going to kill this, and then go ahead and close this again. And now if I try this again, we see that the server is listening. Everything good so far? Yeah.
Wait, sorry, can you just go like one more time over why you can't just use like Redux step directly, have to use Webpack to like create a bundle.js?
Yeah, sure. I mean, yeah. So Webpack just basically helps you transpile from ES6 to ES5. But what it does on top of that is any imports that you do, it's actually going to go ahead and require those files, transpile those files as well, and then append it all into one big-ass file that you can send to the client. Because otherwise the client has no way to get this, basically. Okay. No worries, dude. Okay. So, so now we have this app from last time, the to-do app. When I add an item here, I wonder if all of this works still. So let's say like I put in phone. Okay, cool. And if I remove, did we do remove? Oh, we did. Okay, cool. I feel like the functionality is self-explanatory. Right? Oh, wow, that line of sunlight is not in a great place. Okay, cool. Does anyone have any questions about what this app does? You just add items and you can remove items, right? Okay, cool. So this app is structured as follows. There's like a high-level app which contains like a to-do list container and this thing called to-do list actions. To-do list actions is nothing other than these two items here, which is an input bar as well as a button to add whatever was in the input bar and create a new to-do list item. Now, to-do list container is a component, so we can step into to-do list container. Oh wow, don't know what's going on there. To-do list container, which is coming from here, and so I can step into this file. Now I'm in to-do list container. To-do list container basically says, okay, so for each, so one is that the to-do list container is connected to Redux. I'll talk about how that is structured in just a second. But what it's going to do is get all of the to-do list items that are currently available in Redux, and for each of those items, it's going to render this thing called to-do list item. Okay. To-do list item is essentially just broccoli in this X and then phone in this X. First of all, renders like the item name, and then it renders this button. And when the button is clicked, this button is going to dispatch an action to Redux, and that's going to say like remove like the item from this list that has like this name, this item name. Make sense? High level? Okay. Let's go ahead and look at what this. So the beginning of any React application is here. Okay, this is all code I wrote from last time, just for anyone who's concerned. Just get like a high level like glance into it is what I'm going to do, but I would recommend you watch the previous lecture to like figure out what's going on here. So just to recap, here is where I have a reducer. Okay, what I've done here is basically made a state copy, and I copy the state, which essentially starts off as a default with broccoli and like souse. And when there's a new item, I add that new item to the state. And when I remove item, or when I get an action with the type remove item, I basically return. I just return an array, which is nothing other than the previous state filtered with items that are not the item name that we wish to remove. Does that line of code make sense? Filter just basically accepts all items that match, that return true for the function provided. That's all that does. Yeah?
What do you need to do state.size?
State dots, okay, so from within a reducer, you always have to return a new copy of the state, right? So with numbers, it's like pretty like straightforward because numbers are always like, numbers are not mutable in JavaScript, but objects and arrays, so objects are mutable and arrays are objects, so arrays are mutable. So the problem is I could push to an array, but it's still going to be the reference to the same object in memory, which we can't have within like the framework of Redux. You need to have a new object every time. Okay. Otherwise, it's not going to like register that something changed. It does it by reference. Okay. And then we basically provide this reducer. So now that everyone knows that word, I'm just going to change this to reducer. We pass in the reducer to create store, and then we create this store. Then what we do is we say, okay, we have this line of code called react-dom.render. React-dom.render basically takes a React application that you can pass in, or basically a top-level component. It's going to basically execute, it's going to replace whatever HTML element you provide as a second parameter with whatever you provided as the first parameter. So we have this thing called react-root. So if we look in this index.html, we'll see we have this div with an ID react-root. What this block of code is going to do is replace react-root with this React component. This React component initially was just app, which is the to-do list like app container thing, but we needed a way to provide the store to every React component recursively, right? Because it's like a tree. So what we do is provide this. We use this thing called provider, which is like a higher level component. I got provider from this package called React-Redux. The provider takes in a prop, and a prop is basically just a way to pass data into a React component for those that were here. And basically I'm passing in the store as like a prop to the provider, and the provider in turn is going to provide the store recursively to all children, which include app. So now if we go ahead and look at app, we're back here. We have this to-do list container, to-do list actions. Let's really quickly just go through to-do list container. I'm getting this function called connect from React-Redux. What this function does is it takes in a mapping from the Redux state to the props that I want to be provided to the React component, which are essentially just sections of the state. So if you can see this, it's like the state here is just like a list, right? It's just like it's the broccoli and sauce list. I just want to have this state available to the React component. The way I can do that is through props. So now I can access this.props.redux TL items. So this will get merged into the props of the React component, and then I can access the state that is provided by Redux, and that's handled through like this line of code. Does that make sense? Like, is there like a clear point of confusion here, or is it general confusion or no confusion? Feel free to speak. Okay, I will take that as no confusion. Okay, and then let's look at, yeah.
What is the default for again? Export default connect maps to props.
So export default just basically means like export whatever comes after default. Connect is a function that takes in a mapping from Redux state to the props of the React component, as well as a second parameter, which I'll talk about in just a second. Then the output of connect is a function that takes in a React component. The React component that is taken in will be provided all of the props as per the mapping that you've defined in map state to props. That make sense? You just like pass out? Okay, does that make sense to people? Sorry. All right, let's do it. So to-do list actions, right, is the so to-do list container. Now we have to-do list item, right, which has like this item name. And if we go into to-do list item, which is from to-do list container, everyone follows like the hierarchy of the component so far. That's important. So now I go into to-do list item and I see like this button is being clicked. When this button is clicked, it's executing this.props.remove item with like the item name that was passed in. Remove item is coming from map dispatch to props, which is nothing other than the second parameter to the connect function, right? As you can see here. Basically, I'm saying like this component doesn't need any of the state from Redux, but what it does need is the ability to dispatch, right? The ability to dispatch actions. So when this thing is clicked, I'm going to execute dispatch with the action of type remove name with like an item name. Yeah.
Dispatch is passed into it.
Yeah, dispatch is just like something you can assume that it'll have. Connect will pass dispatch into it. Okay? Does that make sense? Okay, cool. So that's how that works. And the to-do list actions is like a very similar thing where when you click on the add item button, it's going to go ahead and dispatch a new item with whatever like you have typed inside the input field. Make sense? Okay. So now what I want to do, so how much time do I have? I have like 20, 25 minutes? Oh, good. All right, let's do it. So what I want to do is like instead of having, so notice now if I just put like a new item here like chalk and I add it and I refresh the page, it's just like all gone, right? Because it's all like held in like, it was held in memory, I refreshed the page, the memory got cleared, and I reloaded the page, right? That's kind of stupid because you're not like going to have your browser open while you're doing to-do lists, while you're taking care of your to-do list, and you're not going to like not refresh. So what we should do is like have this state be stored somewhere else. What we can do is actually store it on a server. So what we're going to do is make an API server, and then we are going to allow our React application to talk to our API server and manipulate state like elsewhere. Okay? Does that make sense? Does that make sense? Motivation as well? Okay. So what I'm going to do is make, does everyone know what the word API means?
Can you go through it again?
Yeah. So API stands for, what is it, Application Programming Interface, I think. But basically, it's just like a constrained way of external users reacting with or interfacing with your program is all an API is. So basically, I provide a set of functions to the world and say, you can only manipulate me, the program, through this like set of functions that I've exposed to everyone else. So has everyone take like 110 or 120? Yeah, basically like an API for a class is a set of public methods that you provide, more or less. Okay. So what I'm going to do is make an API router which is going to be an express router. And this API router is going to take two things. So it's going to have like a to-dos route. And we're just going to send the to-dos. And let's just say like the to-dos are just available as an array on the server. Okay? And then I need to be able to take in one more thing, which is a post request on /todo. And let's just assume in the request body, so the new to-do is just going to be rec.body.todo. Do people, is this familiar so far? The body of a post request, I'm just basically going to have a property called to-do, and that property to-do is going to be the new to-do that I want to add to the to-dos array. Okay. And then I'm just going to push the new to-do into the to-dos array, and then I'm going to, let's just send like the to-dos again, or let's just say everything went well, send a status code of 200. Okay, and then finally, I want to be able to attach this router to my app. So I'll just do app.use on the API. Basically any /API routes, I want to have the API router run. So basically if I do /API/todos and I send a request to that, I should get all of the to-dos. Make sense? And if I do a post request to /API/todo, I should be able to add a new to-do. Yeah?
So these to-dos are not stored in like a database?
No. It's just like every time I restart the server, it's going to get cleared out.
Oh, so.
Yeah. So what you could do to make this more persistent is like have a file that you read from and edit, or you could use a database, which I'll probably, if we end up doing that top one, then I'll probably do something like that, but not like a to-do application. Okay, so now what we can do is, so now we have this like as a standalone thing. Okay, does everyone like kind of understands what just happened? So let's just say, let's just go ahead and test this out. So I'm going to restart the server, and I'm going to go to my browser, and let's say I go to /API/todos, and that implicitly sends like a GET request. We see that an array has been returned. Does that make sense? So we know like the API routes are at least like functional. Let's say like I initiate it with like the same ones as before, broccoli with a C, and then sauce, and then let's just do something differentiated from the already existing state. Any ideas? What do you buy?
Spelled right.
No, that's fine. What do you mean right? Okay. Are there two L's or what? Is it just one L? Okay, cool. I don't eat a lot of broccoli. So now if I restart this, refresh the page, we see that those have been included. Make sense? Okay. Now what we need to do is make sure our front end is reflective of the state of the to-dos in the back end, and also give our front end the ability to push new to-dos to the back end, right? So that's pretty much all that's left. Let's do a few things first. So that section that off, we're putting that all to the side. What I'm going to do now is like a quick refactoring of what's already here, so that we can kind of follow the paradigm that I talked about like just like a few minutes ago. Okay. So first is I'm going to make a directory that's going to contain like actions, just things relating to actions. Okay. This directory is going to have two things. I'm going to create a file called actions.js. I don't know why it did that, but then I'm going to make another one called actions/types.js, which are essentially two files that are going to serve the same purpose as I talked about before. Also, can I close that? Oh, that's way better. So let's go ahead to types. First, we'll notice that on this index.js, there's only two types so far. There's new item and remove item. So we're just gonna like define both of these. So we can just export const remove item, and then we can just export const new item. Okay, so I can use those in several parts of the application. So now what I'm going to do is import from actions types, and I can import new item and remove item, and then replace these strings with these. Make sense? What I just did? Okay. So last thing we need to do is like wherever these actions are getting dispatched with these types, I'm going to need to like change them, right? So I can just Command Shift F for those, and go ahead and find them throughout my project. So here we see that it's being dispatched over here in to-do list item, which makes sense, right? Because when you click on the X, it should remove the item, right? So it should be dispatching in this component. So I'm going to go ahead and import remove item from actions and types, and then instead of having the string here, I'm just going to have that variable. People see what I'm doing, like the flow of things? I know I'm going a little fast, but I hope people are catching on. Okay, cool. And then I'm going to have to do the same thing for new item. So we see that that's in, this is index.js, this is in the types, and then it's going to be in to-do list actions. So I'm going to want new item, and where do I import it from? I'm going to import it, from the actions folder and then the types file. Okay, so we've like refactored that part. Good so far? Okay. So let's do, okay. So now that we've like done that refactoring, let's talk about, should I do that last level? Yeah, let's just do it. So there's this like notion of, no, I'm not gonna do that yet. Okay, now I'm gonna talk about like how we handle asynchronous, basically asynchronous code within Redux, or within like React and Redux, and then we'll do like another round of refactoring, and then we should be done. So first off is I need to be able to initialize the state with the state of like the server. So the front end state should contain the to-dos that have been pulled from the server, right? So instead of the default state on the front end being that, we're just going to have it be an empty array. That's the first change that I made. The second thing is I need to be able to, one, make a request to the server, let my React application know that, okay, I am currently getting a request from the server. Then if the request succeeds, I want to tell Redux that the request succeeded, here are the to-dos. If the request failed, then here's the error code, and let me just let you know that it's failed. Okay? So what we can do is, first I'm going to import this thing called Axios. Do people remember what that was? Helps me make, it basically helps me make requests. That's it, to like external services or servers. So I can just say, this is in my index.js file. This is the top level file. People understand like where I'm at? The top level file that's going to bind the React application to the DOM. And this is right after I've created the store. I'm going to go ahead and run axios.get API to-dos. And then when I get some data back, I want to do something with it. So first of all, let's just see if we can console log the data. Do people know what this syntax is? It's like the destructuring syntax. So basically, like in the then block of this promise, I'm going to get an object back. That object is going to have a property called data. What I'm going to do now is basically pull out that property called data and create a variable called data with like the contents of whatever was in here. And that's why I have access to data on line 27. That's like stuff from like last class. That line is equivalent to doing this. Those are two equivalent things. Well, it's really that. Okay, so let's just do this because this is much cleaner. And let's see what happens when I refresh the page. Let's kill some of these other things. So we see that we got the 3 items from the server, from the front end code. Does that make sense? Okay. So now what I need to do is basically like hydrate the store with this like new state. And I use the word hydrate because you'll probably hear that if you like look at more dots later. But now what I want to do is basically like set the state of the store. I wonder if that's like an inbuilt function. It probably isn't the. Yeah. Okay. Maybe not. So I'm gonna make like a new like action type, which is gonna be like, let's say like let's just call it like initialize store. It's like pretty. That makes sense, I think. So we'll say initialize store. And basically this action is going to have like the store. So I think I can just return action.initial store. Okay. So note that I still have to like define all of these things. So first of all, I want to be able to import initialize store from the types file. So let me just make this easier to read. And then I'm going to go to the types file, and I'm going to define that. So export const initialize store is equal to initialize store. Right? So now I can import it. So this import should be successful. The last thing I need to do is actually like dispatch this action. Right? So I can say store.dispatch. The type is going to be initialize store, and then I'm going to say initial store is equal to data. Does that make sense? So basically when this request succeeds, it's going to dispatch an action to the store with type initialize store and another property called initial store, which points to the data that was returned. So when that action is dispatched, it's going to come into the reducer, match on this case, and then set the state to be equal to whatever is available on the property initial store of the action. Yeah? And if you want to see the action come in, we can just console log it. Okay, so let's see what happens if I refresh the page. We see that initialize store was triggered, and then this is what was available under the initial store property. Make sense? Okay, cool. So now what I need to do, that's my like get like the whatever was in my to-do list. I need to be able to like push to my to-do list. So let's make another one called like add to-do like success, and we'll kind of like deal with this later. Okay. So first of all, add to-do success needs to be added to the types, right? So that I can import it. And then I need to be able to dispatch this action from to-do list like actions, that component, which basically has the input and the button. That make sense? So first off, when add to-do success occurs, or actually let's leave that. What I want to be able to do is in to-do list actions, when someone clicks on the button, I need to do a few things. So let's make this a multi-line function. And what I'm going to do is Axios, why is it? I don't like that. I can just run axios.post API/to-do with like the to-do as like in the body of the request, right? So basically the second parameter to axios.post is the body of the request. And then if it's like successful, it's going to return. And here I can just dispatch, what was it called? It was called something. It was called this, add to-do success. Add to-do success, and then that's just going to let me know that like it happened. Like I was successfully able to add the to-do. Does that make sense? Yeah? Okay, so just to see that like this is going through, in my server, I'm going to go ahead and just like log the new to-do that came in. Okay, so restart the server, refresh the page. Add to-do success is not defined at the reducer index.js 30. So I'm going to go to index.js. In the reducer, add to-do success has not been defined, which means I have not imported from the types file. Do people see what just happened? Good. Refresh the page. We have this. Maybe like I'll do hello, add item. Looks like it failed with a 500 internal server error, which basically means my server died for some reason. So let's go ahead and look at what like the issue is. Cannot read property to-do of undefined. Oh yeah, okay. So here I'm assuming that I can access rec.body.todo. So cannot read property to-do of undefined, which means rec.body is undefined. Does anyone have any ideas why that might be? Subtle point from like a few lectures ago. Does anyone remember body parser? body parser is a middleware that allows us to actually read the body in this fashion. So what we need to do is just use that real quick. So what I can do is first import it. So body parser is equal to require body parser. And then I'm going to use body parser.json, which allows me to read request bodies with JSON data types. And then I'm going to do URL encoded, which allows me to read request bodies with form data types. Okay, and go ahead and restart my server, and then refresh this page, and then type in like chalk, add the item. Okay, so first of all, we'll see that chalk has been received on the server side. That makes sense? So the request went through. The last thing that's happening is within to-do list actions, I haven't like imported this, so it's just telling me here that it's been undefined, right? Uncaught in promise. So what I do now is say, instead of just new item, I'm going to have add to-do success. Okay, and then that should work. But now we have the problem that my like to-do list is not like refreshing itself, which is a bit of an issue. So what I want to do from the server side is instead of just sending a status code of 200, whenever someone adds a new to-do, let's just go ahead and send like all the to-dos, right? So that they like know what is the current state of the server. So now that I have that, I can restart the server and go to to-do list actions. And whenever someone, so now in the response of this request, I should be getting like the new to-dos, right? Does that make sense? Do people know why I'm getting the new to-dos? Because I'm sending that as a response. Some sort of yes, no. Okay. So server, get a post request to /to-do, add the to-do to the to-dos array, send in the response to the to-dos array. To-do list actions, I send a post request to /to-do, /API/to-do. Then I'm going to get the to-dos array back as this like parameter data. Let's just pass in this data parameter or this data value to this action that's getting dispatched. So now in my reducer, I want to be able to handle this add to do success action type such that it actually updates like the state of the store. So if I go back here in add to do success, let's actually return action.todos. Yeah. Okay. So I refresh this page. If I write chalk, I get chalk. And now if I refresh the page again, we see that chalk is still available because it's pulling the state from the server. Now the last thing that we want to do is, as you can see, like there's like a lot of code here that I could reuse. Like I might be adding to-dos from somewhere else in my application, and also it's like a little dirty to have all this code available or all this code just in like React components. So what I'd rather do is like abstract it away into a separate file. That file is going to be called like actions.js. So here I'm just going to import Axios, and then we're just going to say like, add to do is going to be a function. So we're going to export this function called add to do, which is going to take a to do item name or like the new to do, and then it's just going to run this this block of code. Or actually, let's go ahead and it's going to take in dispatch. It'll take in dispatch as well as like a new to do, so that it can actually dispatch to Redux. And I'll show you like the next 5 minutes how to make this like a lot cleaner. So we have this add to do function. Now in to do list actions, I can actually just import that action. So import add to do from actions, and instead of this function with item name, so instead of what was here, I want to execute add to do with the new item name as well as, or I think dispatch came first. Does that make sense so far? Yeah.
What exactly is dispatch?
Dispatch is the function that is provided from the store that allows you to dispatch actions to the store. So that's just available here through this thing. You don't have to worry too much about like how it gets there. So now, if I refresh the page, it should work, but maybe not. Add to do success is not defined, and that's because in my actions.js file, I have this add to do success thing, but I haven't like imported it. So let's go ahead and import that from the types file, refresh the page, and we see that it worked out. Okay, so that's lit. I don't think I can talk about the next thing. So I'll probably just post I'll post this code. I'll post 2 versions of this code. I'll post this current version, then I'll post like the most clean version, which is going to use this thing called Redux middleware. Redux also has like a notion of middleware that allows you to do async dispatches like a lot more cleanly than is done here. Yeah, but that's basically it. Does anyone have any questions? So high level, what we covered is like you have your React code. Your React code had a bunch of like state in each component. That's kind of messy. So we should move that state to Redux. Redux is like a high level state management like library. So now all of your state is available in the Redux store, and you have a very clean way of manipulating the state that's in the store via dispatching actions. You have a way now for each of your components to independently access the state from the store as well as dispatch actions to the store. So now your components don't have to like pass function handlers to each other. So for example, we can dispatch actions to the store by using this block of code. So map dispatch to props is going to take the dispatch function and provide that to your React component via props, and that the internal mechanics of how that happens is covered by this connect function. Okay. Similarly, we can also map the state that is available within the store to the props of any React component by using map state to props and providing that as a first parameter to the connect function. And that's it. And I showed you how to handle like async things. And likewise, like in here, so in this action, notice how we are only handling like the good case when everything goes well. Similarly, we can handle like add to do rejected, which is basically like we're going to dispatch an action that's going to let Redux know that we had an error in trying to get the to-dos or in posting the to-dos. Got it? Any questions? Okay, cool. Have a good weekend.